I come to the next position here, and that's called orientational paradigms, which doesn't tell you anything. And I must first, well, the outline is this. I will first tell you what the problem is I'm discussing here in this next chapter, because that is somewhat different from the normative or descriptive theories that I discussed so far. So first the problem, and then I tell you what the first step is toward the solution of that problem, namely orientational paradigms. I'm going to explain that to you. I give you examples, and then we look how in orientational paradigms are integrated into systematicity theory, whatever that is, but I'm going to explain that to you, and then I'll have a conclusion. So I tell you the problem. The problem is this, that so far none of these positions of general philosophy of science discussed, they really fit economics. And you see that the result is then, of course, that economists are not interested really in general philosophy of science, because all the offers on the market, there are others also which I did not mention. Laudern is one, and Feyerabend another one, and Lakatosh. But if you look at them, nothing really fits. The discussion in the 60s, 70s, and 80s has disappeared more or less, and economists saying we don't get anything from them, right? It's useless for us. So this is the case. And of course, in Kuhn's framework, one could identify economics together with the other social sciences as being in the pre-normal or pre-paradigmatic phase, right? This pre-normal with these schools and so on. In the literature, social sciences have been described as multi-paradigmatic paradigmatic sciences, or science with coexisting paradigms. That's roughly what Kuhn described there. As schools in the pre-normal phase. One can do that in the social sciences. So for instance, political science, sociology, linguistics, education, sports science, others have been described as multi-paradigmatic. And of course it is then at least not implausible to say, well, economics belongs there too as a multi-paradigmatic science. However, this description of economics as multi-paradigmatic does not seem to fit economics either, because somehow economics seems to be different here. Economics is not just a set of competing schools with different, possibly even incommensurable viewpoints. You know, incommensurable being that they can't even talk to each other. Somehow economics has more unity in comparison to the other social sciences. I discovered that when I talked to economists, then for instance, Ernst Fehr said, look, we have economics is 20 years ahead to the other social sciences. Why? Because we use game theory, right, for instance. And that is something, well, not every economist uses game theory, but that's certainly a somehow not universal, but it's a tool that's used. And also, I mean, it seems to be also other economists, when you talk to them, say, yes, we have more unity than the other social sciences, than sociology or psychology. And I took that seriously, and then I thought, well, this is interesting. How is that unity produced in economics? What is happening there? So economics as a whole, including neoclassical microeconomics, macro, behavioral economics, neuroeconomics, seems to have more unity. Somehow economists can better communicate with each other than different factions in the other social sciences. I mean that they have quarrels and arguments all the time, but still there is some difference. And the question is, how can this be characterized? And this was how I thought that's an interesting problem. So the question is, what sort of unity, if any, does economics have in comparison to the other social sciences, right? It seems to have a little more unity, and that's at least the question. Now, the first step towards the solution is called orientational paradigms. So I'm going to explain to you what orientational paradigms are. On the one hand, of course, economics is one of the social sciences and shares some of its characteristics. That's quite clear, meaning dissensus about many, many fundamental things. On the other hand, economics seems to be closer to the natural sciences than the other social sciences, namely having some sort of unity. Not the same sort of unity that physics has, you know, that there is no fundamental discussion about solid-state physics or quantum mechanics in physics. It's less than that, but it's, on the other hand, it's not quite as, you know, pluralistic as or antagonistic as the other social sciences are. So somehow economics is somehow in between these two. And that's then the question, what makes the specific difference of economics to the natural sciences on the one hand and to the other social sciences at the other? So what does it mean to say that economics is somehow in between the other social sciences and the natural sciences? I mean, that sounds good, but you've got to say, what is it? I mean, what does it mean that it's in between? In which particular sense? And here I have a thesis that I'm going to defend. Economics is special by having orientational paradigms. So paradigms, this is the Kuhnian stuff, but now something new comes, orientational paradigms, that's something else. And the claim is that economics is special in comparison to these other discipline groups, that they have orientational paradigms. And then I got to explain what are orientational paradigms. Now, I give you some examples before characterizing them, that you know what I'm talking about, what the examples are. For instance, expected utility theory is an orientational paradigm, the rational expectation hypothesis, Friedman's The Methodology of Positive Economics, Akerlof's model of asymmetric information, Nash equilibrium, efficient market hypothesis, simple DSGE models. In macroeconomics, you probably are familiar with all of that. You all have heard something of it, know more about it, and they are example of orientational paradigms. So this is, so to speak, the target. And I now want to characterize what role they play, these things, these examples, in economics as a science, and how to characterize them. And I'm going to characterize these orientational paradigms by contrasting them with Kuhn's paradigms. I mean, the name, I stole the name there. So paradigms, but I say it's not Kuhnian paradigms, what economists have. They have something else. It's something somehow weaker than Kuhnian paradigms. I call them orientational paradigms, and you will see why I call them orientational paradigms. So the first thing is that orientational paradigms are, like Kuhn's paradigms, shared across the pertinent communities. So the pertinent communities, meaning every economist knows neoclassical microeconomics, really everyone. Microeconomists may not be familiar with DSGE models, but every macroeconomist knows these models. So many economists know game theory, and so on. So these things here that I mentioned are really known to all economists, or at least large subgroups in economics. I once gave a talk in Mannheim for economists and philosophers, and then after the talk, a student in her first year or second year came, and she said, you know, what's plausible about your orientational paradigms? I've heard of all of them, right? And this is exactly right. So you just learn of that, you're just familiar with that. Whereas in other social sciences, such knowledge that that is so well known across the community, that's different in the other social sciences. So, like that is similar to Kuhn's paradigms, shared across pertinent communities. So every physicist knows quantum mechanics. Some people know only a little, but every physicist knows quantum mechanics, of course. And that implies that all economists of the pertinent community know the respective orientational paradigms, and some of them are even known to all economists. That's what I said. So every economist knows of them. So Nash equilibrium, expected utilities are just, again, these are just, everyone knows them. Knowing doesn't mean subscribing to them. But every economist heard of Nash equilibrium, even if he thinks it's a bad idea, right? Or even if he or she thinks expected utility theory is a bad theory. But you don't find an economist who does not know of it, right? And people may know of it and criticize it. So in order to criticize it, you must know or should know it, right? So this is the point. This is just known across the community. Then the second thing is, and that's now the contrast to Kuhn's theory, the kind of sharing of orientational paradigms is different from the sharing of Kuhn's paradigms. What is the difference? In the respective communities, orientational paradigms are not generally accepted as binding guidelines for further research. What they are in Kuhn's case, right? Quantum mechanics is just a binding guidelines. There is no possibility of saying, I don't like it, right? I don't work, well, you can say I don't work with it, but you can't say it's false, that's not possible at the moment. But what you can say is, Nash equilibrium, no, that's not a very good idea. So, or expected utility theory. You may say, yeah, I know it, but I'm a behaviorist and I don't believe it. I think it's fundamentally wrong. The idea of rationality is fundamentally wrong. So you know know it, but you not generally accept it, but some people may accept it, but it's not generally accepted. And that's the difference to the Kuhnian paradigms. Orientational paradigms are only seen as common points of orientation. That's the point, and this is where the term comes from, orientational. So this is, I think, the best example is here, microeconomics, expected utility theory. This is a point of orientation for everyone, for neoclassicists, orthodox neoclassicists, for behavioral economists, for neuroeconomists. Everyone can refer to microeconomics there to expected utility theory. They may criticize it, they may subscribe to it, but everyone knows what it is, and you can describe what you are doing by contrasting it to expected utility theory. Best examples, of course, Kahneman and Tversky, 79, or Thaler, finding anomalies. Anomalies are anomalies in relation to something which you know, and say, it's different, this doesn't apply. The neoclassical economics doesn't apply. You have to know it, and then go and say, it's false because this and that doesn't comply to its ideas. Orientational paradigms are thus not fixed points of belief, but fixed points of reference. Right? You don't believe, as a behaviorist, you don't believe in neoclassical economics, but you refer to it, and you know that all other economists will understand you when you refer to microeconomics to expected utility theory. And here the examples, of course, expected utility theory. This is one of the most beautiful examples in that respect. Or Friedman's F53. We're going to discuss it. Many people refer then to Friedman, say, this is different from Friedman, or that's the same as Friedman. So people refer to it as a point of orientation. The third characteristic is that orientational paradigms are not further developed and articulated by the whole community, as is the case in Kuhn's paradigms. Some people do further develop it. So some people, of course, still working on expected utility theory and developing it, but it's not that the whole community does it. That's different, say, in physics with quantum mechanics. I mean, if you are there, then you work, if you work in atomic physics or molecular physics, you're using quantum mechanics, period, and you're developing further. And all the molecular physicists do that there, or molecular chemists. And that's different. Some people do develop it further with orientational paradigms. Others criticize them and only use them in order to show what's different, what they are doing. They are just, that's not the source of normal science in which the whole community participates. Right? So expected utility theory is known to everyone, but not everyone works with it and develops it further. But they only use it, say, look, what I'm doing is different in this and that respect to expected utility theory. This does not exclude that parts of the relevant community indeed further develop and apply orientational paradigms. So there are people, Gould and Pesendorfer, we'll see that later, I'll discuss them. They are really the best known orthodox defenders of neoclassical expected utility theory. And there are people using that framework even to understand preference reversal in animals. Right? This is very much, I heard a talk a year ago. There was someone, giving a talk in which he preference reversal, meaning that you prefer A to B, and then the appearance of a third possibility C must not, of course, reverse your preference. It's independent. If you prefer A to B, then you should still prefer A to B. What C does is a different story. But it should not be the case that the presence of C makes you choose B instead of A. But that happens empirically, and then people try to explain that on the basis of orthodox expected utility theory. So people really working with it, that looks like an anomaly, that you say, oh, preference reversal, oh, that's irrational, blah, blah. And then people say, no, if you look very closely, we can explain it with neoclassical economics. So still people working it, developing it for such strange cases. But not everyone. Other people say, yeah, here you see again how bad it is, right? And we need behavioral economics. Okay. Then the next characteristic here, that during normal science, Kuhn's paradigms are not the subject of public and publishable criticism. So you can't publish today in a leading paper a criticism of quantum mechanics, why quantum mechanics is wrong. Well, unless you make an experiment that shows it, but no one was able to do that. So this is just not possible to say that because people say, no, you must have really strong arguments. But in economics, of course, you can criticize everything in economics. right? Whether you get in the very, very best papers, in the 5 AAAA papers, that's a different story. New economists have difficulties there. But this is publishable and to do publicly. And then you are perhaps a heterodox economist, and people won't invite you in Princeton, perhaps, or wherever. But this is just part of the scientific discourse. Whereas Kuhnian paradigms are not, the criticism of paradigms is not part of the public and publishable discourse. Orientational paradigms are open and severely criticized by at least a part of the pertinent scientific community. And that has been in economics always the case. There's always some heterodoxy flowing around. Then, like Kuhn's paradigm, something again similar to Kuhn's paradigms, but not that important. There are different types of orientational paradigms. They come in different sizes and different degrees of generality. So some of these orientational paradigms are very general theories, including exemplars, and some of rather special models. That's the same in physics. So what Kuhn calls paradigms comes in very different sizes. So a paradigm is, for instance, quantum mechanics as a really broad overarching theory, but it can be something rather special. Certain parts, say in solid state physics, where you have a paradigm and only a few hundred people know of it in detail. So that's the same here. So this is a parallel. Expected utility theory, for instance, being extremely general versus Akerlof's model of asymmetric information. Only those people who are really in information economics or where asymmetric information plays a role are then familiar with it. And also, of course, Akerlof's model is an orientational paradigm, that at least all those people working there are aware of it, some use it, some criticize it, and so on. All right. And then, like Kuhn's paradigms, orientational paradigms are historical entities. They come, flourish, and go. So this is, in science, all this stuff that says something substantial is subject to historical change. And the going of Kuhn's paradigms may be their transformation into orientational paradigms, but that's a different story. That happens from time to time, you know, that a theory that was completely accepted and then 20 or 50 years later is not accepted anymore, but people still refer back to it, although nobody believes in it. So Bohr's model of the atom that you still learned in high school, possibly or heard of it, that's really an orientational paradigm. Nobody believes in it, but also today, I think, in the introductory classes in quantum mechanics, you learn Bohr's model. And people just refer to it, and therefore it's an orientational paradigm. Anyway, but that's not that important. And the point is now that due to orientational paradigms, economics has a particular position, a peculiar position between the natural sciences and the other social sciences. This is the thesis. Namely, that economics shares with the natural sciences the common possession of paradigms, but the orientational paradigms are not necessarily seen as binding exemplars for further research, right? So everyone knows of expected utility theory, but only few people or a part of the economic community works with it and accepts it, right? And build models from it. So this is something similar. So they have something in common, like the natural sciences. But on the other hand, economics shares with the other social sciences the lack of some substantial common ground that Kuhn's paradigms supply, right? So as a physicist, quantum mechanics is the way to go, period. And that is something that economics does not possess, right? And it's in that respect then similar to the other social sciences. So it's in between somehow. The other social sciences, however, typically lag or have much less orientational paradigms that provide a controversial, though common basis for communication and exchange across all schools and directions within the discipline. So this is something which I heard really from economists quite often, that they say, look, we can all talk to each other, whereas sociologists cannot talk to each other. They don't understand each other. We economists, we do and we disagree, but we understand what the other person is saying. Why? Because they can refer to the orientational paradigms. That's the explanation that I'm giving here, right? Because we can describe, whatever you do in microeconomics, you refer back to expected utility theory and say, I'm I'm disagreeing with expected utility theory here and there, and then everyone understands what the person is talking about. And you see that wonderfully, especially in Kahneman's and Tversky's paper. And they're really modeling everything on expected utility theory, and this is why they were successful, whereas other people who criticized expected utility theory or Homo economicus and stuff like that were not successful because the economists said, yeah, I don't know what you mean, and you don't understand economics. But that was the success. So it's therefore so important to have these orientational paradigms for economics. The communication exchange across all schools and directions within the discipline, that's easier in economics. Also, of course, sociology has some sorts of orientational paradigms. I'm here on somewhat shaky ground because one should make, of course, the statistical analysis now of economics and compare it to sociology, and I don't know how to do it bibliometrically. It would be a large thing. So this is rather hypothetical. It's my impression that there is a difference between economics and the other social sciences. Now, I give you a few more examples of orientational paradigms, but I will do it quickly because I should finish this chapter today. And I just mentioned it. I give you more literature. There are various examples across the different subdisciplines of economics, and I have 3 chosen here. Expected utility theory, I mentioned several times. Also Nash equilibrium, game theory, and the efficient market hypothesis in asset pricing. And especially examples 2 and 3 were done together with Nicolas Wuttrich. That's acknowledged. We started this work together. Okay, but I'm doing it very, very quickly, and you can read more about it. Now, I mentioned it. Expected utility theory is the centerpiece of post-World War II neoclassical economics. You're all familiar with it. What type of paradigm is it? Well, it's a very general theory, right? I mean, concerning individuals, individual firms, and so on. It's clearly a common point of reference for all economists. That's absolutely trivial. It's not anomalously accepted as a correct descriptive theory. Also not anomalously accepted as a normative theory, by the way. It's not clear that people accept that, but everyone knows it. And especially behavioral economics deviates from expected utility theory and is typically characterized and presented by its deviations from expected utility theory. You probably took that simply for granted, when you used it and then read behavioral economics or so, but it's remarkable. It's very important because understanding that and then understanding the other orientational paradigms in economics, you may get a feeling, at least this is my impression, and this is the content of this hypothesis, this is really what makes economics different, having these orientational paradigms. Okay, example of course, I mentioned Kahneman and Tversky's prospect theory, explicitly developed in contrast to expected utility theory. The figures and formulae are such that the deviations from expected utility theory are readily seen. Instead of p, they write pi and stuff like that. And then and the graphs are just exactly, and you see immediately as an economist where the differences are. And this is, of course, immensely easing the understanding of that alternative theory, which is, of course, for neoclassical economists horrible. I mean, to have all that, deviation can't be true. Anyway, but this was, it's a masterpiece of science communication, what Kahneman and Tversky have done there. I mentioned it. And then, of course, also explicit in Thaler's research program, fundamentally based on the identification of anomalies, namely, in anomalies, what are anomalies? These are deviations from what you expect, right? Anomalies are deviations from what you expect. So you must know what you expect. Otherwise, you don't have anomalies, right? If you go somewhere and you have no idea what's going on there, there's no anomalies because you don't expect anything. So you can only have anomalies if you have expectations. And for the expectations, what is it? Well, expected utility theory. These are the expectations. And then you say, wow, this is differently now, at least descriptively, for instance. So I rush through the Nash equilibrium. That is mutual best response reasoning. Given each player knows the equilibrium strategy of the other players, no player has anything to gain by changing, only his or her own strategy. This is Nash equilibrium. It's a very general theory. It's a common point of reference. Here is, I corrected the numbers in the slides. They are the older numbers, 9,700 plus Google citations, which is a lot, right, in economics. It's in every textbook on game theory and microeconomics. And here's a quote: in the last 20 years, the notion of Nash equilibrium has become a required part of the toolkits of economists, so well known that it does not need explicit citation. Right. This is when you're really great, when your work is cited, everyone knows it, but no citations anymore, right? Yeah, we know it anyway, right? It's not unanimously accepted as correct, and therefore as guideline for further research. There are two widely acknowledged problems about which I am not a specialist: failure of predictive power of Nash equilibrium, and the equilibrium selection problem is one of these, and there are three solution strategies. Nicholas informed me: redefine the payoffs, refine the refinement of Nash equilibrium, and the solution concepts that are not refinements, team reasoning. The alternative positions are clarified in relation to Nash equilibrium. So when you work there, this is just the point of orientation, where you say why you hate it and what you do differently. So this is a wonderful example also of an orientational paradigm. Similar with the efficient market hypothesis, also an example by Nicholas. Financial markets fully reflect all information at a given point in time. That's a hypothesis, and it's a common point of reference. Here we have 33,000 Google citations. That's really a lot, right? 33,000 citations. Anyway, it's in every textbook in finance, in the intro and in pricing theory. It's been called a near dogma since the early 1970s. But it's not anonymously accepted as correct, and therefore as a guideline for further research. It's facing two widely shared criticisms: big bubble events, for instance, .com and the 2007 crash. Asset prices do not follow a random walk, which is presupposed in the market hypothesis. Again, different solution strategies: defense of the hypothesis and behavioral finance. And again, the alternative positions are clarified in relation to the hypothesis. Again, this is the core property of the orientational paradigms. It's a point of reference, right? So the next step is, so this was very quick, and I don't have the time more, but I hope it gains some plausibility. And I cannot defend this orientational paradigm idea to more than plausibility. It's not more. It's not there more. But what I can do is I can show you now, and this is the step 2, why orientational paradigms are a good idea to have. Right? It was very vague so far, and I'm making this now more systematic. And the question that I'm going to answer now, let's assume that economics has orientational paradigms. Is it advantageous for economics to have orientational paradigms? Is that a good idea to have inner science orientational paradigms? Is it really so that therefore economics in some sense is more successful or more efficient than the other social sciences? Now, when you ask how could I ever answer such a question, whether that's a good idea to have them, it should be answerable in the context of a general philosophy of science that tells you in general how sciences work. Then in that framework, it should be possible to answer the question why having orientational paradigms is a good thing, because it increases the efficiency of a science. So we need something, a context, a general philosophy of science. Well, unfortunately, if you look at these philosophies of science which we discussed, and also those which I didn't discuss, the 20th century general philosophy of science, they cannot smoothly accommodate orientational paradigms. So orientational paradigms don't fit into the Kuhnian framework, they don't fit into the Popperian framework, and also if you take the other frameworks, they really don't fit into it. So we can't get a better understanding, a deeper understanding of the role of orientational paradigms by asking these philosophies of science from the 20th century. They just don't do the job, unfortunately. No, but there's another theory which is called systematicity theory, and there the role of orientational paradigms can be understood, and I gave you the reference for that theory. Okay. Now, what is systematicity theory? It's a general philosophy of science that is supposed to cover all research fields, all of them, all what is in the German word Wissenschaft. You know, science is usually natural science, but not the Geisteswissenschaften, the moral science or humanities. But systematicity theory is a general philosophy of science covering all research fields, including mathematics, the social sciences, humanities, the engineering sciences, and the natural sciences. So that's the ambition of that theory. It's a very ambitious, almost suicidal theory. But so far I've survived. Okay, now the main thesis of that theory is this. Scientific knowledge differs from other kinds of knowledge, from everyday knowledge in particular, primarily by being more systematic. So that's a very short sentence, right? Scientific knowledge is more systematic than other forms of knowledge. That's in one. And that looks very, very simple, but it takes a whole book to develop this idea and make it plausible and argue for it. And of course, I can't do that here, but that's the basic idea. And what I'm trying to show you now is that given this basic idea and made plausible, you can understand why orientational paradigms can play a role for those disciplines who have them. Right? So, now this thesis, which looks so simple, just being, you know, more systematic, it covers several dimensions or aspects of science, claiming for science a higher degree of systematicity in these dimensions. So it just doesn't say globally scientific knowledge is more systematic than everyday knowledge, but it says very specifically there are 9 aspects in which science is more systematic than everyday knowledge or professional knowledge, right? And I'm not developing this systematically here, but for instance, the thesis then applies to descriptions and says scientific knowledge is, wherever you go, more systematic regarding its descriptions in comparison to everyday knowledge, right? Or regarding explanations. So also in everyday knowledge, we make explanations. But if you compare then everyday explanations with scientific explanations are more systematic than the everyday explanations. And there are 7 other dimensions, which I'm not mentioning here at the moment. So one can then, once you have developed that, one can then say, or characterize the progress in science in general, whatever field it is, to say the progress of science consists in the increase of systematicity aggregated over all 9 dimensions. So you as economists, you know what aggregation is. The other scientists, many of them don't know that so well as economists do. But the aggregation is the fundamental thing. And it's, of course, complicated. Aggregation is never simple. It's almost never simple. And it's not simple here either. But that's the basic idea. You've got to aggregate these increase of systematicity in the 9 dimensions. And if you look at the development of a certain field, then if everything goes okay, then you can say the systematicity of this field develops because in these dimensions, systematicity increases. And if you aggregate that, then the all over systematicity of that field increases, and that is scientific progress. Okay, that needs, of course, much work to develop this. I'm not arguing for it really and make it plausible. The point is now that if you find this at least not utterly absurd, that you say, okay, let's consider this idea. The mainly relevant dimension for the appreciation of the role of orientational paradigms are 2 dimensions that I have not mentioned yet. This is epistemic, so-called epistemic connectedness and critical discourse. So to bring you up to date again, in case you passed out for a moment or so, there are 9 dimensions that are claimed to be relevant. Well, I should do that. 9 dimensions, right? 9 dimensions that are relevant. And I mentioned descriptions, explanations, which is plausible, but here are 2 more, epistemic connectedness and critical discourse. And the point is that orientational paradigms increase the systematicity, in particular concerning epistemic connectedness, and particularly in critical discourse. They are not that relevant for the other dimensions, but these are the relevant dimensions. So if you see that, then systematicity theory makes it understandable, intelligible, why having orientational paradigms is really an asset for a discipline, because it increases the possibilities of systematicity increase, which means scientific progress, right? More efficient science production, knowledge production. All right. So, For that purpose, I have to explain to you what epistemic connectedness is. Now, epistemic connectedness means that different parts of a science cohere in various ways with one another. In science, there is nothing, in all the existing science, there is nothing that's completely isolated without any contact with the rest of science. It's interesting, for instance, if you look at chess theory, if you don't know anything about chess theory, I mean, the openings in chess theory, there are books of 900 pages just for one opening in chess. It's highly systematic, and you have just for endgames, you have an encyclopedia, and it's incredible. But it's not a part of mathematics. But you would say, wait a minute, why not? Why not? I mean, it's systematic and people do research there and innovation and it really looks like science, but no one claims that chess theory is a part of mathematics, right? Take a different thing, Sudoku. There is a Sudoku theory, right? For instance, the question in Sudoku is, what's the minimum number of numbers you have to have in this field? It happens to be 17. Right? And people really started to investigate that that's a part of computer science and combinatorics. And it's quite, if you find it in the internet, and it's quite clear, this is a part. Why is that so, that Sudoku theory is a part of mathematics, of information science, and chess theory isn't? Well, chess theory has no bridges to the rest of mathematics. Right? What game theory can tell you about chess is completely uninteresting. Right? But chess theory is completely decoupled. And it's not a part of science because it doesn't have any bridges to the rest of science, to the rest of mathematics. Sudoku theory does have these bridges, therefore it counts as that. So what you see from this example, of course it's only one example out of a necessary 2 million examples, epistemic connectedness is something that characterizes the science. So if you can increase the epistemic connectedness of a science by something, that increases the systematicity, because epistemic connectedness is a part of all the kinds of systematicity that are aggregated. All right. So different parts of science cohere in various ways with one another. And of course, it's obvious that orientational paradigms increase the degree of epistemic connectedness of various parts of economics because there are common points of orientation. You know, they connect. If you have expected utility theory, it binds together everything, neuroeconomics, and so on, wherever it's there. And this is why it's taught already in Economics 101, because you need it everywhere as a piece of knowledge. I mean, you don't have to believe it, but you have to know it. And this is the function, and therefore it's quite obvious that orientational paradigms, by being, common points of reference, increase on an epistemic level concerning the knowledge and propositions and whatever, and hypotheses and so on. They increase the degree of epistemic connectedness. So systematicity theory explains to you, yes, that's a function of orientational paradigms. They increase the degree of epistemic connectedness. The other dimension, this is one of the dimensions, right? And there's another dimension which is called critical discourse. Question? No. The other is critical discourse, which means that we have, it's not an epistemic dimension, but it's a social dimension. It tells you that in science we have many institutions where critical discourse is it's institutionalized, that people discuss and critically question each other. This, of course, in science, it's everywhere, right? You give somewhere a talk is given, you have interruptions on questions, you have review reports, you have book reviews, you have referee journals, and so on and so forth. So science is full of critical discourse, right? Necessarily so, and there are well-established social institutions. So they are there, and of course, orientational paradigms, by their epistemic function, namely connecting these, they increase the possibility of critical discourse. Different schools can discuss their differences with recourse to these fixed points of reference. So, of course, this is enabled, the possibilities are increased to have a critical discourse. So economists can talk much more to each other than psychologists from different schools or cultural anthropologists from different schools. And this is because economists have these orientational paradigms. They can say, they can pinpoint their differences by saying, you know, I believe in expected utility theory, or you deviate at this point, so they can talk to each other. But when you try that a behavioral therapist tries to talk to a psychoanalyst, then it may be very difficult whether they understand each other. They don't have orientational paradigms, apparently. Thus, according to systematicity theory, having orientational paradigms is advantageous in comparison to not having them. And this explains this story. Okay, yes?
Do you believe economists will still be able to talk to each other in, say, 50 years?
Oh, I have no idea. You know, I'm not a prophet. I'm a philosopher of science and not a philosopher of science fiction. So, I don't know. I have no idea how all this develops. No idea. I don't know. So far, economists have been, within the last decades, been very successful to have this stock, an increasing stock of orientational paradigms. It's not discussed as that, but if you read Roderick's book, you know, about economics, who says economics is the science of models. And many of these models really play the role of orientational paradigms because they're so widespread. So many models, everyone knows them. You may not like them, but you know them. And you can, of course, then refer to them and discuss them, so you get epistemic connectedness and you get critical discourse. How that will develop, I have no idea. I don't know. I mean, Thomas Kuhn said in the 20th century, he's not sure whether science will survive in the present form in the 21st century. I don't know. I'm not that pessimistic about it. I simply don't know. I would be surprised if economists would not try to further develop these orientational paradigms, because, I mean, it makes economics much stronger than not having them. Okay, conclusion. Orientational paradigms set economics apart from many other social sciences. As I said, I mean, one has to be very careful, and it's a little hypothetical, because one should have a bibliometric study of really finding, you know, identifying them and then comparing different social science disciplines. So this is a rather vague impression that I'm having, and in discussions, but so far it seems to me a plausible thing. Now, orientational paradigms don't provide things to a profession that are accepted as valid throughout, in comparison to the Kuhnian paradigms, right? They don't do that, but as points of common orientation, they do it. And that's already better than not having them. That's my main point, right? Don't exaggerate their importance, but it's better than not having them, and having a discourse around, you know, the problems is a big advantage in a science. And the positive function of orientational paradigms for a science can be understood in the framework of systematicity theory. Of course, I'm biased here, but I try to explain that, and I really believe it. Okay, and here you have references for the examples. And this time, well, you have a sort of holiday now for 1 minute or so. Thank you very much. Unless there are any questions? No, thank you. See you next week.